Hi everyone,
Hi, it's Alfred.
and Sumrine.
Welcome to our live stream. This is episode 106, and in this episode we'll be going over how to set up your Matrix Creator as a TV remote. So using the IR sensor on the Matrix Creator, both the receiver and the transmitter, to get your remote controls IR signals and then send it back to your TV. And right now, we're going to interview Robert Wolf, and he is the community manager at 96Boards. So just a little bit about him beforehand. He is the community manager at 96Boards. He's been a community leader, technical writer, engineer, does a lot of things with STEAM in academic institutions. And yeah, here he is.
So Robert.
Hello. Hi, how are you?
Good. How are you doing?
Good, thanks. Thank you for having me.
Yeah, no, thank you for being on. So I guess let's get right to it. I guess could you tell us about Lenaro and 96Boards?
Yeah, sure. So, hi everyone. My name is Robert Wolf. I am an electrical engineer out of San Diego, and I'm currently working as the community manager and engineer for 96Boards, which is a department within a company called Lenaro. So Lenaro, we are a global company. Roughly translated means Linux on ARM. So basically, Lenaro was started back several years ago to reduce the redundancies and fragmentation in the Linux on ARM ecosystem. Now, back in those days when this company first started, it was really hard for developers to get their hands on the hardware that they needed to develop, right? So if you wanted to work on ARM, you either needed to spend a lot of money and wait a long time. There were long lead times on these boards to get your hands on the hardware you needed to develop. So 96Boards was started, which is my department here, to create low lead time, low cost, SoC agnostic development hardware. Now we can get these boards into the hands of the developers so that they can get their stuff done. And, later on, I can show you some of this hardware. I have a nice little board here full of all of my little gadgets, and all these boxes here are full of my stuff. But in essence, what we're trying to do is we're trying to develop an ecosystem of SoC agnostic hardware that follows a strong standard so that you can kind of use this hardware, transition across different SoCs, system on chips, if you're not aware of the acronym, different system on chips, develop and get your work out there.
Yeah, that's great. I mean, I guess could you show us some of the boards?
Yeah. So actually, I have a bunch right here. So breaking it down a little bit more, right? So 96Boards, we have right now currently 3 specifications. These are open hardware specifications, so you can go in to 96boards.org. Definitely suggest checking that out. If you click the About section, there's a specification link there, and you can go through these specifications. One is the Consumer Edition, one is the Enterprise Edition, and the other is the IoT Edition. We do have more specs coming out. They've already announced our SOM spec and our automotive spec, but those are not available just yet. So what I'm going to show you is a few of the consumer boards and maybe a couple IoT boards. But basically, this is actually the first 96 board that ever existed. This is a high key, which is featuring the Kirin 620 chipset on here from Huawei. It's right underneath this heatsink. And what I mean by consumer edition spec and kind of an ecosystem built around a unified footprint, yet SoC agnostic, is that you can take another board right here. You have the exact same footprint, the exact same I/O, the exact same pretty much everything, but you're working on different chipsets. So on the right hand here, which is probably your left, I'm not sure if this is mirrored on the cameras, but the blue one is a Dragon Board 410C. This is featuring the Snapdragon 410E chipset. Whereas on this one, I said it has the Kirin 620 chipset by Huawei. Now, what makes this nice is that, say one day you're working on this chipset, you say, hey, you know what, I kind of want to explore the Snapdragon chips. Or maybe I'm transitioning from this type of development to another type of development. You can move your work from one chipset to another and somewhat seamlessly stay within the ecosystem. So the hardware or the peripherals or the extender boards that you're using will just kind of mirror over to your other boards. And that's where the standard comes into play, with the I/O being, basically mirrored across all the different chips and boards. I have a bunch here. So like I have a Xilinx board, again, like the same footprint. Yeah. I have a Kirin 960 board, which is again, same footprint. I have a Rock 960, which is the RK3399 board. That's a pretty popular chip by Rock Chip.
Yeah.
So yeah, there's a lot of fun things to play with.
Nice.
Cool.
Yeah, no, that's we really like the platform. Just the ability to have the same I/O board with different socks, and then adding in different mezzanines to it too. What mezzanines have you guys made? And I guess maybe explain for our viewers who don't know what a mezzanine is.
Yeah, so I think the best way to describe a mezzanine is kind of synonymous or equivalent to what you would say a hat is to a Raspberry Pi, or a shield to an Arduino, or a cape to a BeagleBone. So a mezzanine attaches onto your board and breaks out some sort of functionality or peripheral to what you're working on. Sorry, I'm looking at the YouTube and I see that Sahaj said hi there. Hi Sahaj, what's up? Sahaj is one of the Sahaj is the 96Boards engineer. So thank you for coming here. So I'll give an example right here real quick. So if we're looking at this board right here, I'm pulling up the Dragon board again, but you see we have the low speed header, and then we have the high speed header right here. So you can't really get your wires in there to wire that up, right? Yeah. Maybe you want to break something out or extend some functionality out of the high speed header. Well, you get these boards, mezzanine boards, they clip on top of your board, and here what you can see, this is actually one of the newer ones from Shiratech and Aero Electronics. You have an FPGA chip on here. It breaks out an Arduino kind of pinout here, and then it also breaks out a Raspberry Pi pinout, and it adds a few Grove connectors here. But I can take this right here, and I can just plug this onto the board. Make sure it's powered off when you're doing stuff like this. But plug it on, and then I've added, the Raspberry Pi ecosystem. I've added the Arduino ecosystem, and I still have my 96Boards ARM chipset on the bottom that I can work with for any of my heavy lifting.
Yeah.
And you can put these boards across all the boards, right? Because the headers match up. It's essentially the standard.
Wow, yeah, that's a great concept. I love the concept of having Arduino and Raspberry Pi compatibility.
Yeah, and what other types of mezzanines are out there?
Yeah, I can throw a bunch up here, actually. You don't see my desk, it's a mess. But so, here's another one. This is a Bosch sensor mezzanine. So it has a bunch of sensors on here. Again, the same low-speed, high-speed connectors. This gives you access to a bunch of sensors. I have a Hope Run Secure 96 mezzanine. This just goes into the low speed. This is for security, anyone who's working in security work. I have a Argon key. This is these are little ones. So if I plug these onto a board, it still fits on, but it doesn't take up the whole profile. You can see kind of like that.
Okay.
So these boards, again, they just attach on. This gives you access to a bunch of other little sensors and LEDs. Here's another cool one from Next Biometrics. There's a little fingerprint scanner. So this just plugs in again to the low speed header. Goes right there, so you can scan fingerprints and do fingerprint development. But there are tons of these things, and my board back here is even lined with more. There's camera mezzanines, other sensor mezzanines, ADC, power over Ethernet mezzanines, all sorts of cool stuff. So, and more keep coming out. Pretty much it feels like every week.
Wow, that's awesome.
Super cool.
That's a lot of growing. So, with all these mezzanines and the boards with all the various socks, I can imagine there's a lot of use cases for it. What's one of the most interesting ones that you've seen?
Yeah, so I do a lot of work, like you mentioned, in academics. I like to help out around universities and K through 12 when possible. They do hackathons over at my alma mater at University of California, San Diego every year in January, the Hard Hack. And there's two projects in particular that I really liked. Now, there are some other ones out there. I know there's been some really cool projects that have been done, even probably way more complex than these, but these had a really particular use case that I enjoyed. So one was they took a 96Boards, they attached a camera to it, they wrote a bunch of code, and essentially what it was is they would put a camera in a parking lot, in a parking structure, and it would be able to monitor, say, 50 parking spaces, okay? Then what they did, this was all in 24 hours, so this is why it was amazing. But they took that, they attached the camera, it could monitor 50 spaces, then they linked an application to this gateway, and every time a car would park into a spot, it would read the license plate and it would check a database to see if that license plate was a valid license plate, if they paid their parking, right? So right now the current system is you park, you get out of your car, you walk over to the little station, you pay with your credit card, you get the ticket, you walk back to your car, you put the ticket. They have meter people going around checking all the cars, see if you have your ticket. Waste of time. It's a waste of resources.
Yeah.
This camera does it all. You pay on your application. It communicates with the 96 boards. It detects whether or not all of license plates have paid or not. And then it sends a notification to the law enforcement if one of the license plates wasn't there. So I thought that was a pretty cool one. I could share more, but I mean, I could talk about this for a long time. If you want
No, I mean, that's amazing that they did that in 24 hours. And I mean, that's a system that, you know, people who own parking garages would pay, I'm sure, thousands, if not tens of thousands of dollars for. So that's amazing that they were able to do that in that time. Wow. Yeah. Yeah. So, hold on, let me look at my questions here.
So, like, we ran into Robert at ARM TechCon.
Oh,
so,
yeah.
Robert had his own cool project. You want to talk about that?
Gosh, yeah. I wish I had it on me right now. It's still up at the ARM office here in San Diego. I haven't gone to pick it up yet. But, yeah, so I have been an advocate of, or an evangelist advocate, kind of pet projects of mine have all kind of surrounded this renewable energy or solar energy. So like for the last 10 years or so, I've had a lot of fun building solar projects. And I think I created a project several years ago. And then I came across some students. They created another project that was kind of like based on my idea for building this little handheld solar kit. And then David Tischler from Mini Nodes, if you're not familiar with Mini Nodes, go search it on Google. Awesome company. Approached me and said, hey, we should build a new version of your solar kit and we should put a mini node in it. And basically now this is creating a self-contained, self-sustainable mobile server or mobile whatever you want, right? Because you could just throw a bunch of sensors in there, drop it in the middle of the forest and detect earthquakes, whatever you want.
Right.
Or you could drop it in a village and give internet to a village. So that's pretty much it. It's a self-sustainable, self-contained, handheld, mobile ARM development kit. And we didn't want to classify it. We wanted it to be like the foundation and let people decide what they could do with it.
It's like a
Should I share some pictures?
developer kit. Oh,
Yeah.
sure, if you want.
Yeah.
You could maybe share your screen, I think, on the Google Hangout, and then our viewers would be able to see it. But
Yeah, I think I posted some on Instagram here. Let me see if I did.
Yeah.
Here. So I'll share my screen real quick.
Cool.
Present. Ooh. So this is it right here, actually.
Yep, that's what we saw.
Yeah, so here you can see we had a little screen built in. Here's the charge controller. Is my mouse showing up? My cursor?
Yep.
Here's the charge controller. Here's some batteries, and we left enough room to add even more batteries if you want to, build up your power supply. Then you have an inverter here, which is not necessarily necessary, right? You could also remove that and just work off 12 volts. And then this section ended up being filled up with David's mini node. And then in here we had a Dragon board 410C with an LTE mezzanine. So we weren't even running off of the event's Wi-Fi. We were actually running off of our own LTE network.
Oh wow!
So it was pretty cool.
Nice.
Yeah. Here. Let me see if I can do one more thing here. I think there's a video of. I don't know if the video will show up. Let's see. This is him just powering it on, so you can see like.
It's like powering on a spaceship.
Like
or a
5
plane.
buttons.
Yeah.
Nice.
Oh, that's awesome. No, I mean that kit. It's kind of like how, like you were saying, it's a base for you to then go out, put anything in it, to then go make your own thing. It's like a 96Boards, kind of, but for going out into the world. That's really awesome.
Very nice.
I can think of a lot of things you could do with that.
I'd like to see some, like underserved areas of, the world get access to kits like this, because you're not only giving them connectivity to the world, right, which means they can now learn things, access the internet, but you could also send things like this out with prepackaged curriculum, right? And teach people how to code, in remote areas of the world.
Yeah.
Villages and all over the place could probably use stuff like this. And it would be amazing because just plant a solar panel, give some boxes out, and they could even share a solar hub. Every day in the morning, the kids go plug in their kit, charge up their battery, go to school, and all sorts of applications. But that's one of my favorites to think about.
Yeah. That's
No,
an amazing
amazing.
idea. Yeah.
And so do you have like the instructions for how to build it online, or are you guys selling it? Like, how's that work?
I kind of do have some instructions here. I did put up in our 96Boards projects org. So let me share this link. I guess you guys can post it over onto YouTube if you want.
Oh yeah, on YouTube, and then we can also like show it right now, like scroll through it right now.
Yeah, so I just shared the link in the Hangouts chat. But basically, what we plan on doing with this box is open sourcing everything. So in this link that I just shared, all of the STL files are there. I tried to share the bill of materials best as possible. Unfortunately, it will be somewhat limiting depending on where you are in the world because the case I bought at Home Depot, right? So we discussed this, and for the third revision of this box, what we want to do is we want to find distributors on a more global, have more global access, right? I just went and bought that box from Home Depot. You might not have a Home Depot somewhere in Europe. I don't know. But so if you were able to get this on like Alibaba or some sort of global distributor, then that's what we're going to focus on. Building even a cheaper kit, but yet more robust with smaller print sizes. So if you look at the back panel of this one, we had to print that in 4 pieces. We want to try to get a single print for that. We want to make all of the parts smaller. We want to bring the charge controller down, the inverter down, and just kind of make the kit more robust while simultaneously making it smaller.
Yeah.
And open sourcing everything. Yeah.
That's awesome.
Yeah, so, I mean, that's like a great initiative, and looks like, you can do a bunch of stuff with 96Boards. How's the community looking? Like, it's obviously growing, and, like, tell us more about your community, and, like, maybe your podcast as well, Open Hours, because, we're going to be on that sometime next year.
So, the community, 96Boards community is amazing. Something that I always get asked is, what is the difference between 96Boards and Raspberry Pi, right? Our community is not, I want to say, competing or different from those who are on Raspberry Pi. I feel that we complement each other, but yet with Raspberry Pi, you're going to see a lot more makers, people who are interested in tinkering and building out, fun little projects, and that's awesome. And I encourage everyone who plans to, maybe come tackle one of our 96Boards to experiment with a Raspberry Pi first. And then the 96Boards community is more filled with kind of developers, people who are getting down and dirty on a low level and working on the kernel and working on all these different types of drivers and GPU and lots of things on that level. However, that doesn't mean that we don't welcome makers to this ecosystem. As you can tell, a lot of our vendors, a lot of our distributors are very much interested in getting you access to a wide variety of peripherals and functionality through these mezzanine boards that they're pushing out. So we are kind of slowly starting to cater to the maker community. So nice. I would encourage everyone to go check out 96boards.org to see if you can find something that interests you.
Yeah, for sure. And since you were saying it's mostly a lot of developers, do you see more people using your board to develop, to prototype, and then going off and making their own, or actually using 96Boards in like a final product?
That's a good question. I'm glad you asked that because I should have already covered that when I was talking about this. 96Boards actually does specialize very heavily in path to product. Okay. So we are a partner-based company. A lot of our partners, do encourage the path to product kind of model. And when you are working with 96Boards, you are working with the industry standard. So a lot of our boards are bleeding edge technology. You're talking about things that are basically the buzzwords of today, like AI, deep learning, machine learning, automotive, and stuff like that. Our boards cater to the people who want to tackle these, bleeding edge problems and solutions, let's say. So yeah, the path to product is something that we definitely focus on, and we try to drive with our message, people who are working with 96 boards.
All right.
Awesome.
Well,
yeah.
96 boards is super cool. Like, definitely go check it out. We are, running close to, the time we should start wrapping up. Do you have any, anything else you'd like to share with, our viewers and the, hardware developing community?
Any cool things coming up with 96 boards?
Yeah, so we actually, I'll just take just a minute. We do have a lot of really cool things coming up, especially this time of the year. We will have a lot of new boards coming out, so definitely keep your eyes on 96boards.org and at 96boards at any social media, outlet, Instagram, Twitter, LinkedIn. Go find us at 96boards. I would also encourage, like you mentioned, I do host my own podcast. It's a video podcast similar to this one every week, Thursday at 4 p.m. UTC. It's called Open Hours. And can I share that link? Is that okay?
Yeah, sure.
Yeah, so 96boards/open hours. And I'll just post it here in the chat. So maybe you can throw that into YouTube.
Yeah.
But basically what we do every week is we try to interview someone or talk about some sort of interesting tech subject. It's not necessarily always about 96 boards. Last week we spoke to a postdoc in psychology who studies chronic pain, but she built us a 96 boards out of sushi because that's how she teaches science to people. She builds sushi art, and then she's able to teach all these really cool science topics or STEM topics to people. And then tomorrow we'll be interviewing someone that works on the Tron blockchain. So we kind of cover everything all over the place. Yeah. And then sometime next year we'll be talking with you guys.
Yeah, I think we're scheduled for sometime in February.
Yeah. So, keep your eyes on the Open Hours website and on our social media, and you can find out what's coming up this week.
Awesome.
Or
Great.
each week. Yeah.
Great. And so I see there's one question in the chat. If anybody viewing has a question, post it now. And the question is from Kevin. He's asking, could you ask if they are trying to connect the matrix boards with some of this, with some of the 96 boards? So to answer that question for you, Kevin, and we had discussed this already with Robert. I don't know if we had told you the final answer, Robert. So the Matrix Creator, Matrix Voice isn't compatible with 96 boards, mostly because of our kernel modules and the voltage that the 96 boards run at compared to the voltage that the Matrix Creator and Matrix Voice run out, which is made for the Pi. And that's 3.3 volts versus, what was it? 1.8. Yeah.
1.8.
Yeah. So right now, no, but in the future, perhaps we'll make a 96 board mezzanine creator thing. So we'll see. The future is long.
We would very much like to see that. So yeah, absolutely.
Yeah, awesome. So is there any other questions in the chat? It doesn't seem like it. So I guess with that, we can wrap it up. Thank you for joining us, Robert. It was great.
Yeah.
Thank you, both of you, for your time. I really appreciate it, and thank you for the interview. For the talk.
Yeah. It was great to learn more about it, and there's lots of cool projects going on. 96 boards, it's versatile. Let's just say.
Yeah, no, there's a lot of things you can do with it for sure.
Yeah, so thank you for being here, and looking forward to talking with you in February next year.
Yeah. Oh, one quick question I had wanted to ask. I just remembered. What are you guys going to do when you reach 96 boards?
Okay, so that's actually a good one. 96 boards actually never really stood for us trying to reach 96. I would say after our 96 board, we'll do our 97th board. but in essence, 96 board stands for 64-bit plus 32-bit, and that's where the 96 comes from.
That makes sense.
So that's where it came from. Hopefully we'll have 96 boards one day, and hopefully we'll pass that number right up.
Awesome.
Sounds good.
Great. Well, thank you for talking with us, Robert, and have a great night.
Thank you. Thank you very much.
Thanks. Bye.
Bye.
Great. Well, that was awesome. Wow, there's a lot of there's a lot of things you can do with those boards.
Yeah,
Just, like,
I didn't know that you could do Raspberry Pi and Arduino stuff. That was like
yeah, the Mezzanine on it. That was cool. And that Mezzanine has an FPGA.
I know.
So I guess that's what's handling the connections between the Arduino, the Pi, all the way to the the sock on the 96 board.
Yeah, probably. It was really cool. Really cool to know about that. Yeah. All right,
Awesome.
so
Great.
I guess we'll be moving into our next segment, which is going to be the Matrix Creator as TV Remote, which is going to be coded by Carlos.
Yeah.
We're going to switch to a screen where you can't see us switching our seats, and
Why not?
I don't know.
Okay.
For professionality, I guess.
Wow.
All right, and then here we are. And this is Carlos, and I'm
Hello.
Submarine. Haha. And Alfred's name tag is currently not there. But, alright, take it away.
Alright, so what we're going to do here is we're going to use the IR emitter and receiver to control a TV through a website with the Matrix Creator. So if we can get started, can you change the screen?
Yes. I will change the screen. Let me first go here, and then go. Cool.
Alright, so to get started, on our GitHub, you'll find a repository called Matrix TV Remote Website. So this has all the instructions you need to get started from a fresh Raspberry Stretch installation. For this installation, we'll be using a Raspberry Pi with Raspberry Stretch Lite, which is just a terminal version. So to get started, we're just going to follow the instructions step by step. So really quick, we'll just open up our terminal. And then you're going to want to SSH into the Pi. Oop, half and half. Oh, that's fine. Alright, so let's see. It should be pi at 192.168.1.
You did a comma instead of a dot.
Oh, my bad. 192.168.1.81. See, that should work. There we go. So we'll connect to the Raspberry Pi, put in the default password, which is Raspberry, and we're good to get started. So first up is we already have a GitHub repository that lets you get started with IR, which is called Matrix Creator IR Test. And from here, you're just going to follow steps 1 and 2. Here, you can even see a little GIF here where it shows you what the end result's going to look like. So we're basically going to make a wrapper around this repository to just control it through a website instead of a terminal. So the advantage of that is that you can pull it up on your phone and control your TV or any IR-enabled device. So one by one, we'll start copying it.
Quick thing, Carlos. Could you switch the terminal to be on the left side? Because we have the video on the right side.
So what you can do is go here and make it smaller, like
Okay.
and then hit the terminal and put it.
The thing that I can do here is...
Or you can do something better.
Yeah, right.
That works nice.
Alright.
Okay.
Awesome.
Very nice.
That way it doesn't get blocked by your video.
Yep, sorry about that.
Cool.
So moving on, we'll just start installing all the necessary packages to have all the dependencies needed. So as to save time, we've already done this, but this is just to walk you through and show you what it would actually look like if you started from scratch. Only difference is that we're doing this a lot faster. So installing and updating all the packages we have on our Pi, as well as installing the Matrix packages, which are coming up right now. There we go. Alright, and then we'll reboot. Well, here we won't reboot to save time, but after you reboot, so just, pretend. Should be a quick guide. Alright, so now that we have all the basic dependencies installed, we're going to install this dependency called PyGPIO, which is what we use to actually control the GPIO pins. So what we'll do here is, and through the GPIO pins, you can actually call the IR emitter and receiver, which, let me install this real quick. So if you look here, this is a pin that we have with the Matrix Creator attached to the Raspberry Pi, and what we're doing is using GPIO, let me see if I can zoom in to show you better. We're using here GPIO 13, which is the IR transmitter, and then GPIO
16, right?
16,
Up
yeah.
there.
No. Yeah, 16, which is the receiver. So one to record commands and one to emit commands. Okay, and what we just did right now, pip install PyGPIO, was installing the Python dependency. So because the program to record and send IR messages is written in Python, so we'll need that. And then that should be it. From this repository, we only needed step 1 and 2. And now we can actually just close that. And back to the TV repository here, the website. So once you have the dependencies installed there, you're going to want to do sudo pygpiod on your Raspberry Pi. What this does is actually start pygpio. So with that started, which this has to be done on boot each time, but we'll show you how to have it your Raspberry Pi do it automatically. You're also going to want to install Git to download this repository to have the website and everything else set up. So we'll do that right now. And really quick, should be cloning. Alright, and just to prove it, there it is, the TV remote folder. That has everything you need to get started. And it's also written in Node.js, so we're also going to install that onto the Raspberry Pi. Oh, my bad. And copy that. Alright, that shouldn't take too long. We're going to install Node version 8.6 because it's compatible with our Matrix core layer.
Alright.
Okay, so that should almost be done. There we go.
Nice.
And just a sec, we could type in node-v, and there we go, version 8.6. So now what we're going to do is go into our repository and install all the node dependencies inside. And this is built using Express to host a website and Socket.io to have a connection between the website and the client, which would be your web browser. So that means you can load it up on your iPad or any tablet, phone, any computer. Anything that can use a web browser, it can load this website to control your TV.
Alright, so...
Okay, now if you can, what we're going to do here is that, can you have both this screen and the
other screen?
Yeah.
So what you can do is, you could maybe do three-way? I don't know, but this is the tab with the, so if you join a meeting.
What we do right now, to save some time, we have, is it here?
I'll be back.
Okay, so what we do is that we have a TV positioned over there, and that has a Pi already set up aimed at the TV, so when we start recording command, which is what we're going to do right now, we can just set that up really quickly. So let me just wait for that setup to go by. Is it set up? All good?
1 second.
Some little troubles, so I'll keep you guys entertained.
So in the meantime... Oh,
All
it's
good?
there? Oh, okay.
Okay.
Well, there you go.
Okay, and just to have a better view, I'm going to shrink this and also bring back the terminal so we can actually see everything. Okay. There you go. So, oop.
Alright.
Okay, so there's a TV with the Matrix Creator, as you can see right there, and then the terminal will be right here. So, oop. Oh, the mouse is a little stuck, and then right now we'll go back to the command we were just on. So, close out some tabs, and then okay. Right here, we'll copy this command. What this command will do is that it'll go into the folder that we just cloned for the project and actually run the script inside, which is right here, TV commands. This is what holds the Python script from the other repository. So we'll start that. Oop, did not copy. Copy and paste. There you go. So what this does is that it makes the shell script in there executable, and then it'll run it. And what the shell script does is that it already has preset commands to record and look out for. So I'm going to run that.
All right.
And I'm going to go record the command right now.
So Carlos is going to record the commands. I will let you see him do that, I suppose. Yeah, we can see you. Yeah, wait, what?
You need to share your screen.
I need to share my screen. Sorry. So
yeah,
Carlos needs to be able to see what we're doing.
Present now.
Present now. Sorry about that. Is that working?
I don't see
Click present now again.
Okay.
Yeah, your
well,
entire
now it's
screen.
gonna work. Share.
Okay, and then
All
click
right.
his.
Awesome.
Click his video.
Cool.
Yeah.
All right.
What you can see here, so the integrator is right here.
They can't hear you,
Hold on,
Carlos.
Speak now. Wait.
Well, no, you can't unmute
Wait, no.
him from here.
Oh.
So basically, Carlos is pointing the
Yes.
remote at the Matrix Creator, and on the script, it's telling him to press number 5, number 4, number 3, and it's going to go through all of the possible, or at least all of the main remote commands that you would want programmed.
Mm-hmm.
So every time it says number 8, Carlos is basically, or whatever number, he is pressing the corresponding button on the remote, And the IR receiver on the front of the matrix creator, which if you don't know where it is, I'll show it. Yeah, we're on the video. So it is right above the sensor hole, the little black component. That is the IR receiver. And then above that is an IR transmitter. And on the very back at the top of the matrix creator is another IR transmitter.
Right, so
that's how it's working. Almost done with all the commands.
And FYI, if your buttons are different, you should be able to go into the code and like configure it. You know, like for example, if you don't have a button called input but have a button called source or something, you can go change that. Like really easy to modify. But this is particularly for this remote and it's pretty standard, I think.
Yeah.
But if it doesn't work for you, you can always go in and.
Yeah, and let's say you have other buttons on your remote, like some remotes, like for, let's say, Comcast boxes. You can control the Comcast box and the TV and a bunch of other things. So you could just add in more commands there.
Cool.
All set?
All right.
Okay, so time to go back here. Can you adjust the camera? Actually, no. Actually, we're good here.
Yeah, we're fine.
What can they see? Okay.
So they can see this.
All right, so now that once we have that done, I'll go back here. So all the commands are recorded, and just for people that want to edit their commands or even save them, what you can do is that you can, in the TV remote TV commands folder, there's going to be a file called codes.json. So what this has is every code, every command that you recorded, and the code that goes with them. So if I just print out the contents of what's in there, you can see we have the code for volume up, the code for volume down, the code for up, the code for right. So this contains everything you need, and you can just copy and paste this somewhere else if you want to save this for the future, so you don't have to do the whole recording process again. And then just to start running the website right here, this will go into the project and run the app.js file, which is what actually has the website, or has all the script to manage this. So the server is initiated, so now if I go to the web browser and type in my Pi's here, to visit it, it's your Raspberry Pi's IP address at port 8080. So we're going to type in 192.168.1.81, and the port is 8080. Enter. And here we go. This is a basic website. So this is initially modeled after a Comcast remote that I had, but you can easily just change some letters around and some of the commands to meet your needs. So as you can see right here for the TV, we're just going to raise the volume. Can they see the TV?
No. So if you pull up the TV on this side, that'd be great.
Got it. Okay, so the mouse here is a little bit.
Do you want me to help?
It's good.
You got it. Okay.
Oh.
Just the tap once. Good.
Okay. So to do this real quick, we'll just shrink it. It's also mobile. It's responsive, so it'll work on mobile devices and still look good. So real quick, we're gonna raise the volume, and there you go. On the TV side, you can see it actually being raised the moment we click it, and it's also being logged in the terminal. Another feature is that we also log the amount of users on the website, so you won't have, someone secretly going on there without you knowing. You'll know how many people are using the remote. And if you notice, every time I click around here, there's going to be a light blinking. That's one way you'll know that it's working. See right there on the Matrix Creator, there's a blue light blinking each time I click a button. So let's try right now the guide. So here I had it mapped to the menu button on our control. And you can see that I'm actually controlling the TV without being in the same room. So with this, you can use, for whatever application you want to do, you can actually have a way to control an IR controller without being in the same room or even in the same house if you set it up properly in your network. And yeah, that's the entire guide, just to show you how to get that set up, and yeah, that should be it.
Awesome. Well, I'm going to switch back to this view so we can all say bye, or actually make an announcement before we say bye. Yeah. Let me stick with this screen. ARM Dev Day is coming up. It's in January on the 22nd, and it's basically like a day-long online workshop. You like multiple workshops. Like we're doing one, and then there's 96Boards who we just talked to, mini nodes, OpenMV, Ambient Lab, and Accutronics. So really cool. You get to learn a bunch. And like hear cool speakers talk about their technology. So go check them out, sign up for a workshop. We're doing Matrix Creator workshop I don't know if I should keep it a secret what we're doing, but probably not. I don't know.
Well,
We'll keep it a surprise. Yeah, we'll keep it a surprise. All right. So anyway, join this. It's on Hackster. We'll put the link in our description afterwards. And front cam. All right. So this was our guide. And hopefully everybody enjoyed the interview. If you have any questions, feel free to ask on our YouTube chat or YouTube comments, post on our community, things like that. The usual, and thank you for watching.
A couple more things. So for the guide, the main TV remote guide itself is on Hackster, but what Carlos just showed you is a repo on our GitHub. And within that repo is where we have the actual like interface, the website, basically.
So the guide we have on Hackster shows you how to download the example with PyGPIO. They have a written Python example that we've just added the pins that control the IO receiver and emitter to just control your, to record and send commands. And what this project does is it has a wrapper around that project, so you can interface with it through a website instead. So it's just you could do whatever you want with it. It's just an example of the potential of what you can do.
Yeah, and if you have any questions about that, feel free to post an issue on our GitHub or go to our community.matrix.one.
Yeah, we'll put a link in the description.
Yeah.
Yeah.
Yeah, and I guess that's about it. Let me check the chat.
All right, we're gonna check the chat one more time. But other than that, you can always ask questions at any time.
Yeah, we're active on the community, so any questions posted there, we'll try our best to answer.
Awesome. All right. Well, thank you for watching, and we'll see you in 2 weeks.
Yeah. Bye.
Bye.
Bye.